This video relates to example 10 from our moles booklet, and it's focusing on gas volumes and moles. We've been talking about Gay-Lussac's law and Avogadro's law. Now we're going to look at some of the mathematics of these two laws. So first of all, Avogadro's law: equal volumes of gas contain equal number of molecules. You can rewrite that a different way, and you can rephrase it as, therefore, equal numbers of gaseous molecules occupy equal volume. And that's a way of thinking about, well, if equal numbers of gaseous molecules occupy the same volume, that means 1 mole of gaseous atoms, which is a set number of atoms, will have set volume regardless of what gas it is. And so that led to the definition: the volume occupied by 1 mole of a gas is known as the molar volume. So it doesn't matter what gas you've got, if you've got 1 mole of gas particles, it'll occupy the same volume. But there's a small catch to this. The volume of a gas, as we know, everyone knows this, if you change the temperature and pressure, you can change the volume of a gas. By squeezing it or heating it up, you can change the volume, and we know that the volume will increase if we drop the pressure or increase the temperature. So when you're defining the molar volume, it's very important to specify what temperature and pressure you're talking about. And the two conditions you need to know for preliminary HSC chemistry are that at 25 degrees and 100 kilopascals of pressure, 1 mole of any gas occupies exactly 24.79 litres. That's on your data sheet. You don't have to memorise this, it's on your data sheet. But if you cool it down to 0 degrees at the same pressure, 1 mole of gas occupies only 22.71 litres. And we know that if you cool the gas down, it's going to contract. If we heat it up, it's going to expand. So if you get that 1 mole of particles at 25 degrees and 100 kilopascals of pressure, it'll occupy this volume. Cool it down to 0 degrees, it occupies a slightly smaller volume. And you need to know those two, or the two relevant ones for HSC chemistry. Let's think about how the mathematics of this will apply then. If you've got 1 mole of gas, we've defined that as it occupies 1 mole of volume. So what if you've got 2 moles of gas? What volume is that going to occupy? Well, hopefully you can think about this and realise that if 1 mole of gas occupies 1 volume, then 2 moles of gas occupies 2 volumes. And believe it or not, 3 moles of gas will occupy 3 molar volumes. And that means mathematically, the volume you have is equal to the number of moles of gas you've got times by the molar volume, where, or you can rearrange that to number of moles equals volume divided by molar volume if you wish. But in this situation, V is the volume of gas in litres, MV is the molar volume at the specified temperature and pressure, and N is the number of moles of gas. And that's the equation we're going to use to solve some problems in this example. But just visually, to look at what we're talking about, first thing we said in that previous slide was equal volumes of gas contain the same number of particles. So here are two equal volumes of gas at the same temperature and pressure. Because they have the same volume, there must be the same number of particles in each one. So I'm going to say this, in this particular case, I've got 1 mole of A particles in here, and because this box here has got exactly the same volume of gas, therefore there must be 1 mole of B molecules in here. So 1 mole of any gas at a certain temperature and pressure has fixed volume. But in that case, if 1 mole of gas occupies 1 volume, well, what if I've got 2 volumes of gas? So if I've got 1 mole of gas that's going to occupy a molar volume, 2 moles of gas will have twice the volume, will have 2 molar volumes. And therefore the volume of a gas is how many moles of gas you've got times the volume of 1 mole of gas, which we know is called the molar volume, and that leads to the equation of volume of a gas is number of moles times molar volume. So let's look at our two examples, or two parts of the question for example 10. First of all, if hydrogen gas occupies 90 litres at 25 degrees and 100 kilopascals, how many moles of hydrogen gas are there? And second of all, what volume will 1.033 by 10 to the minus 5 moles of chlorine gas occupy at 0 degrees and 100 kilopascals? So question A, once again, using DeSord, we always put our data down first. What do we know from the question? Well, we know at 25 degrees and 100 kilopascals, the molar volume, look on your data sheet for this, it's always there behind your periodic table, the molar volume is 24.79 litres. What else do we know? Well, we've been told the volume of hydrogen gas is 90 litres, and we also have been told we've got to figure out how many moles of hydrogen gas there are. So what formula can I use that equates number of moles volume molar volume? We just learned about it. Number of moles equals volume divided by molar volume. So now I can substitute my data in. I'm going to put 90 in for hydrogen. I'm going to put 24.79 in for the molar volume. I put that in my calculator, and it tells me that's equal to 3.63. I'm going to come back here now and check my significant figures in the question. These two numbers here are considered like exact numbers. They're actually not part of the calculation. I didn't use 25 and I didn't use 100 anywhere in my actual calculation. The number I did use in my calculation were 24.79 with 4 significant figures, and 90, which only has 1 significant figure. So therefore my answer should have 1 significant figure. So rather than saying 3.63 moles, I have to say 4 moles to 1 significant figure. Looking at B, what's my data for B? Well, the first thing I've been told at 0 degrees and 100 kilopascals, you should look at your data sheet now to see if you can find what volume that is. So pause it and find it, please. Okay, you should have found that 22.71 litres is the molar volume at 0 degrees and 100 kilopascals. Now what else do we know? We've been told the moles of chlorine gas, 1.033 by 10 to the 5. We've been asked to find the volume of chlorine gas, so let's put our formula in place. Volume, we've been told volume equals number of moles times molar volume. We've got 1.033 by 10 to the minus 5 moles times by the molar volume at 0 degrees, which is 22.71. Put that in your calculator and see how you go, putting that number in your calculator. And the answer you should get there is it's 2.346 times 10 to the minus 4 litres to 4 significant figures. Should it be 4 significant figures though? Let's have a double check. This number here, 1, 2, 3, 4, 4 significant figures there. Off the data sheet, our volume, 1, 2, 3, 4 significant figures there. Now, 0 degrees and 100 kilopascals, they're both to 1 significant figure. But if you look at our calculation, we didn't use the number 100 or the number 0 in our calculation. They were just there to guide us to the molar volume. Therefore, we don't consider their significant figures. We only deal with this number and with this number. Both of these are 4 significant figures, and therefore our answer should also be to 4 significant figures.